Welcome back to the deep dive. Today, we're peeling back the layers on, well, one of the most talked about topics in enterprise right now, generative AI ecosystems.
That's right. And we're going deep.
We are. Specifically, we're looking at the architecture, the capabilities, really what defines a modern, secure approach to Gen AI inside a data cloud.
And importantly, we're not just looking at, marketing slides. We're using a structured blueprint, really. Insights from technical knowledge frameworks to understand the actual building blocks.
So this is about the how.
It's all about the how. The goal for you is to decode those critical components that let you run secure, scalable AI workloads inside the data cloud. We're focusing on strategy and implications, not just definitions.
Exactly. Think of this as a high-intensity crash course in what's mandatory for modern enterprise AI to actually succeed. We're moving beyond the hype. We're focusing on the underlying mechanisms that make it functional, governable, and, affordable at scale.
Okay, let's unpack this.
Right.
If we want to build these sophisticated AI apps, especially ones that need to understand our own internal knowledge, we have to start with the foundation.
Yeah.
The mechanism.
Yeah.
We need a way to search not just for keywords, but for ideas.
And that mechanism is retrieval augmented generation, or AG, as most people call it. It's the core strategy for grounding an LLM in your own proprietary data.
But RAG is just an acronym, right? It's just a concept until you have the plumbing underneath it.
Exactly. You need that specialized search capability, and that is vector search.
Let's ground this in a real scenario. Imagine you need to build a chat with your Docs app. Something where users can ask questions of these massive internal PDF manuals, compliance docs, all that proprietary stuff.
Right.
If you just search for keywords, you're going to get a huge, probably irrelevant list of results. And that's the classic failure point of traditional search. RAG works precisely because that search component, the vector search service, finds the most relevant chunks of documents based on semantic meaning.
Semantic meaning. So it knows that car and automobile are related concepts.
Exactly. Even if they aren't the exact same word, it understands the relationship.
Okay, but is that kind of similarity search? Isn't that computationally expensive, especially at scale? Does this mean we have to completely re-index all of our legacy data just to get this to work?
It does require some preparation. I mean, that's true.
Yeah.
But the process is highly optimized. Vector search stores data in a very specialized way as embeddings, and then it just retrieves the closest matches.
Okay.
The real takeaway here is the operational shift. You're turning a slow, brittle keyword match process into an automated semantic reasoning engine. And that's the bridge you need to make internal data truly actionable for Gen AI.
So vector search is the service that gets the results, but it's totally dependent on these things called embeddings. If we want to understand the magic, I guess we have to understand what an embedding actually is.
Yeah, that's the input. Think of embeddings as the numerical fingerprint of your text. If a developer needs to convert raw text, say millions of customer product reviews, into a numerical format for similarity searches, they need that text embedding capability.
It's turning human language into math, but it's not simple math, right? Give us a stronger metaphor for that.
Okay, think of it like indexing a massive university library, but not with the Dewey Decimal System, which is based on these rigid, predefined categories.
Okay.
Instead, you index it by the actual ideas inside the books. Every idea, every concept gets a precise coordinate in this huge multidimensional knowledge space. The embedding is that coordinate.
I love that. So when the LLM searches, it's not looking for keywords. It's looking for proximity. It's looking for things that are close together in that intellectual space.
Precisely. That process transforms text into a machine-friendly vector that represents its semantic meaning. These vectors let the system compare two pieces of text and understand their relationship, even if the wording is completely different.
And that's the key.
That capability is absolutely essential, not just for RAG, but for high-precision recommendation engines, large-scale clustering. Really, any application where understanding nuanced context is critical.
This all sounds incredibly powerful, but, in the enterprise world, power has to come with security, with total control. So once we have the data foundation locked down, the next big challenge is how to deploy your own custom or proprietary models.
And this is the moment when organizations realize they can't just rely on built-in general-purpose models forever. Data science teams, they often want to use their own custom-trained open-source models or maybe niche models fine-tuned on hyper-specific data.
Okay, here's where it gets really interesting. In a regulated industry, that team can't just send their proprietary model and data off to some random external environment. So what's the solution? How do you get that flexibility without breaking the data cloud boundary?
The solution is Snowpark Container Services. This is it's a total game changer for enterprise MLOps.
A game changer how? What's the core security and operational benefit there?
It lets teams run their own models, their own runtime environment, their own dependencies, anything they want, inside the secure compute environment.
Inside.
They package that custom model in a secure container and deploy it directly within the data platform. So you get full flexibility, but you're still respecting all the strict security and governance requirements, because the data never has to leave the platform's perimeter.
Wait a second. If I can just use my own custom-trained model in Snowpark containers, why would I ever bother with the built-in Cortex functions we're about to discuss? Isn't deploying a whole containerized model kind of overkill for a simple task like translation or summarizing a review?
That's a crucial distinction, yeah. Snowpark containers are for maximum flexibility, for complex orchestration or your own proprietary models. Think full-scale MLOps projects.
Okay.
The built-in Cortex functions, on the other hand, are for maximum speed and ease of use on common tasks. If you need to analyze sentiment on a few million reviews right now, you use Cortex.
And if you need to deploy some unique proprietary forecasting model built on PyTorch that has to run 24/7,
Then you use Snowpark containers. It's about using the right tool for the job.
that clarifies the strategic choice. Now let's shift focus a bit to access management, specifically within specialized tools like Document AI. For companies dealing with unique, unstructured content, they need control over how that information gets pulled out. What level of permission gives a user the power to really tailor that extraction process?
You're talking about the ability to build, train, and manage customized extraction models. This permission is absolutely vital for organizations that have unique, proprietary, or just highly specialized document formats, like complex legal contracts or, arcane engineering schematics.
So without that level of control, Document AI would be limited to just general forms.
Pretty much. This is the difference between, say, extracting a name and address from a standard utility bill versus teaching the system to extract 8 unique regulatory codes from some niche manufacturing compliance report.
Right.
It gives them full control over the AI's interpretation layer. They can pull specific high-value information from unstructured content that's tailored exactly to their business logic.
Okay, now let's move into the everyday application of AI for the business user, the Cortex toolkit, which provides these very specific built-in functions. We talked about democratizing data access. How does a business analyst who doesn't know SQL get answers from the database without having to learn a query language?
Well, we're bridging that technical gap with what's often called natural language to SQL. The feature is designed specifically for converting plain English questions, simple human business intent.
Like what? Give me an example.
Like, what were our total sales in the Northeast region last quarter compared to the prior period? Something like that. It turns that question into an executable SQL query.
So it's basically an interpretation and execution assistant.
Exactly. It interprets the business question, it understands the data schema, and it automatically generates a syntactically correct query that actually works. It means data access isn't gated by technical expertise anymore.
And that rapidly improves time to insight for non-technical teams.
Absolutely.
Let's talk about speed for bulk processing. Imagine a marketing team. They're facing a deadline. They have 10,000 recent customer reviews they need to analyze immediately. They need to figure out sentiment positive, negative, neutral before they launch their next campaign.
Yeah, classic scenario.
Which Cortex function is best for that kind of massive repetitive task?
A function specifically designed for analyzing text sentiment. That's the one you want. The efficiency really comes from 2 things. First, it's optimized for massive scale. It can process thousands of rows very quickly. Second, the models are pre-trained and built in. This saves the marketing team from having to, hire a data scientist to build and train their own sentiment classifier. It reduces weeks of work down to minutes.
That is a massive win for speed and for resource allocation. Now let's look at another common AI task, translation. When you use the built-in translation function, it requires precision. What are the 3 essential inputs a user has to provide?
The required inputs are the text to translate, the source language, and the target language.
Why are all 3 strictly needed? I mean, couldn't the system just detect the source language automatically? Most online tools do that.
It could try, sure, but by requiring explicit inputs for all 3, the system avoids making incorrect assumptions. It significantly improves the translation quality and reliability, especially for shorter texts or highly technical content.
So when you're dealing with critical enterprise data, you're choosing accuracy over convenience.
You have to.
Okay, so if ARA gives us broad relevance by finding semantically similar documents, what happens when we need surgically precise information? This moves us beyond general retrieval and into more specialized functions.
Right.
For instance, an analyst needs to find the single best sentence from a massive 100-page research paper that answers a very specific, narrow question.
The most appropriate tool there is an answer extraction function. This isn't just about reading the paper. It's about surgically locating the precise piece of text that satisfies that query.
How is that fundamentally different from, say, a summarization function that also processes long text?
It's a great question. Summarization generates a condensed, often generalized version of the input text. Answer extraction, on the other hand, is trained to locate the exact sentence or short passage that directly answers the user's question. It's built for precision retrieval and confidence.
So it's much better when the goal is to pinpoint a verifiable fact rather than just generate a paraphrase.
Far superior for that use case, yes.
We've covered the technical mechanisms, the custom deployment flexibility, and the specialized tools. Let's finish up by hitting the two principles that matter most to enterprise leadership: governance and cost.
The bottom line.
The bottom line. Let's revisit governance. A core promise here is that the data never leaves the environment during processing. This whole idea of a zero-trust AI boundary, how is that guarantee actually upheld?
This is absolutely critical for compliance, especially in regulated sectors. And the rule is absolute. All Cortex functions, including the LLMs they use, are built in and run entirely within the secure compute boundary of the data cloud.
So they're not making calls out to external public APIs?
Never.
So that guarantee is absolute. The data stays within the platform, governed by the enterprise's existing security policies. What does preventing data from crossing that boundary save an organization in terms of risk or just common security mistakes?
Well, it simplifies audit trails dramatically.
Yeah.
By keeping everything internal, it eliminates the risk of sensitive proprietary data being accidentally exposed or maybe logged by some third-party model provider.
Right.
It streamlines compliance checks, GDPR, IPI, SOC2, because the data residency requirements are just inherently met. It fundamentally changes the security posture of using generative AI from, a high-risk external transfer to a contained internal compute operation.
That covers the secure execution side. Now, billing. Equally important for enterprise budgeting. How are the compute costs for these Cortex AI services primarily billed? Is it a fixed subscription fee, or is it based on the volume of tokens?
They consume Snowflake credits from a virtual warehouse or serverless compute. Crucially, they follow the standard, predictable, credit-based billing model, just like any other workload on the platform.
That's significant. Why is that specific billing model credits applied to existing compute a strategic advantage for someone managing budgets?
It creates cost predictability and unification. Enterprises already understand how their platform credit consumption works. By aligning AI costs with their existing compute structure, there are no surprise invoices from external vendors, no complex token counting.
No need to set up a separate budget for some external Gen AI service.
Exactly. It makes the cost of AI consumption transparent, manageable, and just, integrated into the overall IT budget. Given that both custom deployment with Snowpark containers and massive scale execution with Cortex functions are specifically designed to keep data securely within the platform, how might this guaranteed zero-trust AI boundary fundamentally change the speed and confidence of the development lifecycle for enterprises dealing with the most highly regulated or proprietary data? What opportunities does this unprecedented level of integrated governance open up for you?